Hello everyone, welcome to chapter 9 differentiation, and for this chapter we're gonna have 5 subtopics, and the first one is called derivative of a function. Let's start with the meaning of derivative. So what is a derivative? It is the same as gradient or the symbol m or dy dx or even f prime m. And as we all know, gradient means the steepness of a function. So let's start with the gradient of a straight line is a constant. So note that if you have a straight line, therefore the gradient will always be a constant. So say that you have a straight line passing through 2 points. The first point or the first coordinate is x1, y1, and the second coordinate is x2, y2. So let's look at this graph here. At this coordinate, the x-coordinate is x1 and the y-coordinate is fx1. Let's call that coordinate A. And here we have the second coordinate. Okay, so say that this is x1 and then we have this gap of h here. Therefore, this value is x1 plus h. So if this is the x-coordinate, therefore, the y-coordinate will become fx1 plus h. And let's call that point B. So, how do we find the gradient of AB? We can write the gradient as MAB, and we know that for a straight line, the gradient is always a constant. And this is the formula of finding gradient. You need to use the first coordinate and the second coordinate in order to find gradient. So we need the x-coordinate and y-coordinate of the second point, which is this one. So this is x2 and this is y2. And we also need the x-coordinate and the y-coordinate of the first point. And this is x1 and this one is y1. And by substituting these two coordinates, we will get this expression. Note that for the denominator here, you can simplify it. So x1 minus x1 will just give you h. So now we will get fx1 plus h minus fx1 divided by h. And this is actually f prime x. So note that f prime x is just the same as the gradient. So this is actually the equation in order to find the gradient of a straight line. Now, what if you need to find the gradient of a curve? A curve can be a quadratic function or a cubic function, etc. So note that for any curve, the gradient is not a constant. So let's look at this graph here. We still have 2 points. Let's call this the coordinate A, and the coordinate is x1, fx1. So this is the x-coordinate and this is the y-coordinate. The gap between x1 and the second x-coordinate is h. Therefore, that's why this is x plus h. If this is x1 plus h, therefore the y-coordinate will become fx1 plus h. So this is the second coordinate B. So, let's find the gradient of MAB. In this case, the gradient is not a constant. And we also know that this is the basic formula of finding a gradient. So, we need the y-coordinate and x-coordinate of the second coordinate, which is B. So, this is x2 and this is y2. We also need the y-coordinate and x-coordinate of the first point A. So this will become x1, this will become y1. So substitute these two coordinates into our formula. And we can see that for the denominator, we can cancel out x1. And hence, the gradient, which is MAB, is fx1 plus h minus fx1 divided by h. But be careful, MAB here means it is the gradient between point A and point B, which is this straight line. Which is wrong because this is not the gradient of a curve. Note that the gradient of a curve is the same as the gradient of any tangent lines that touches the curve. So, tangent line means it is a straight line that touches our curve and it can be anywhere along the curve. So, let's say that we're gonna take the tangent line that touches point A. So, let's call that MA, the gradient at point A. We want to find the gradient of AB. This straight line here is wrong because this is not the gradient of this curve. So, what we're gonna do to this straight line here is that we're gonna make this h here to become smaller. So, as we can see, this is the length of h. So, if I make h smaller, let's make it as close to point A as possible. Therefore, this coordinate B will move to this coordinate here. And hence, the new MAB will be this straight line. So now you can see that MAB looks almost the same as MA, which is what we want, as long as h becomes smaller. So what we need is, we need h to approach 0. So this is where we will apply the concept of chapter 8 limits. As h becomes smaller or h approaches 0, we can see that the gradient of AB is almost the same as the gradient of A. So how do we write this equation? Since we have h approaches 0, we're talking about limits. So the limit as h approaches 0. So what do we put here? We need to find the gradient of AB, and we know that the gradient of AB is this. So we're gonna put it here. But we are not done yet. As you can see, to find h, we need to take the second x coordinate minus with the first x coordinate. So h is equal to x2 minus x1. And if you rearrange this, you will get x2 equal to x1 plus h. Instead of x1, let's just call it as x. And hence, the gradient is f prime x equal to limit as h approaches 0, fx plus h minus fx divided by h. And this is how you find the gradient of any curve.